Hi, I'm Matt Marshall, founder and CEO of VentureBeat. We're here live from GTC 2024 talking with Vic Malyala, who is the Senior Vice President of Technology and AI at Supermicro. Welcome, Vic.
Thanks, Matt, for having me here. Yeah.
Vic, Supermicro. A lot of our guests may not be familiar with Supermicro because it's a company that's in the background, but you're doing something really important, right? So GTC is where NVIDIA is showing off its latest technology. They're the GPU company, but you're the company putting the GPUs together in clusters ready to be in modularized form, right? Ready to be used by these scaled enterprise companies. And that has also shown tremendous growth for you, right, in terms of the market cap of Supermicro. Tell us what you're doing here today. Are you making any announcements with NVIDIA?
Now, besides having the buckets of candy outside, yeah, there is a lot more things that are happening here.
Yeah, right there, right? Yeah, too close.
Yeah, so I think GTC is one of the most, if not the most important event for Supermicro and in general for the community today. Mainly because of what is happening in the industry with respect to accelerating everything and how to improve the overall experience of any vertical on any application. And Supermicro has been working with NVIDIA for the longest time. I mean, you might have heard Jensen saying like, Supermicro and NVIDIA started in the same year, which is true, and we've been working closely together for the longest time. So it's not just an overnight glory, but it is something in the making for the last couple of decades. And what happened is that when we take a look at Supermicro products and start adding accelerators to that, that was being used for HPC, that is used for inferencing and machine learning and so many things that were happening for the last several years. But the Gen AI, when it came, the whole thing changed, right? And the good thing is that we are ready and we are already having all these platforms developed with NVIDIA, and given the fact that we are just like a stone throw away from each other companies, we actually took it to the next level by bringing, it's not that easy, by the way, to stay in the same pace as NVIDIA, but we were able to successfully do that and bring the technology before anyone else. That actually made a huge difference in enabling customers and also accelerating the innovation pretty much anywhere.
Great, so when you said everything changed when generative AI hit last year, are you saying change as in just poured on the growth, it's just acceleration, or is it change in other ways? Can you talk a little bit about that?
In every way, right? So, of course, there is a lot of demand suddenly came about anything to do with accelerated computing. That is given, right? I mean, everybody knows.
Yeah.
But what is happening is that the type of customers that are coming up, the type of applications that are being developed, which requires this kind of hardware, some of these companies you might have never heard of their names like 2-3 years ago.
Okay.
Now they are the mainstream. And we are actually able to enable so many different type of customers. That is the one that is propelling this, ridiculous, if not outrageous growth.
So that's a great point, Vic. We have been talking here about this inflection point when you get away from experimentation with generative AI to actual deployment. And there's a question of when that really accelerates in the enterprise. Can you talk a little bit about who those customers are? Those new customers, if I don't know if you have any names you can share, maybe if not, maybe groupings of industries that are driving the change, and are they moving to deployment?
Right, so names, if you just walk around, I would say majority of those are customers are going to be customers, given the fact of what we are showcasing in this GTC event. But what we have seen is, if I were to classify into different ways of customers, some are the end users who know what to do with this gear and who have a tremendous amount of data and also the resources to basically take the data, write some applications, run on these systems to have their business applications accelerate. That is one type of customers. Second is the type of customers who are creating infrastructure to take this gear and make it available for others who do not necessarily have the resources to go do that, whether it is going to be infrastructure as service, whether it's plain hosting and whatnot. And the third category are those ones who are developing applications who need accelerated compute gear in order for them to port their applications and develop their suites and whatnot. So it's a mix of these different companies, but the overlap is happening. I mean, the guys who are developing this infrastructure, they're like, well, I mean, if I'm able to do that, and if I'm able to pair with these framework on different software and make it easy for customers to adopt. All of a sudden, I'm creating a business case for myself and actually enabling different customers. So the good thing is that end users, the infrastructure as service partners, and as well as the small size customers that are developing software and eventually have the ability to scale to this large level. So it's a gamut of all these different customers. The good thing is that since we have products that are kind of starting from very small scale all the way to the massive supercomputers, it's very easy for people to find what is relevant for their workloads and pick a platform based on that.
Great, Vic, thanks. One of the things we saw from Jensen, the CEO of NVIDIA's keynote, is this announcement of the new Blackwell system, right? The super duper, next generation of GPUs, and then the SuperPod, right, kind of data center that comes along with that. They were showing one of your racks that is helping with that back there, but next to Supermicro's rack, you have HP, Dell, and Lenovo. Can you talk a little bit about what's behind the rack? Are they all the same? Is it commoditized?
It's never the same and never commoditized. I think one of the biggest differentiators for Supermicro is application optimized platforms.
Yeah.
What does it mean, right? So we know very well for a fact that no one size fits all. And if you take a look at how these platforms are deployed, I mean, are they going into some co-location? Are they going into a purpose-built data center? Are they going to the edge? Are they staying in a core data center where they have very controlled environment? They have air-cooled, or they have liquid-cooled? And you can start defining all these, let's say, sections of parameters, and then you go back and look at it. You need to get the platform that is right for that. I mean, just in those 4 racks that you have seen in that NVIDIA area, you have this particular one is like a Grace Hopper based. And for those guys who are looking for a densest compute, we have like a dual nodes with a liquid cooling that actually can bring the most efficiencies into the equation, versus people who have networking in the front or back, then we have like a front or rear I/O. Or the people who are looking at optimizing for air-based cooling, then we have a single node based on that. So you can start looking at what is that people want to do. They want to support Bluefield 3, or they want to use ConnectX-7, they want to have different type of I/O. All these things are taken into consideration to come up with different product line. That is just what you are seeing. These 4 racks of things are like multiple variants of just Grace Hopper. Right? Okay. But when you come into the Supermicro booth, you will see a lot more products that are ranging anywhere from that, going into let's say Hopper systems and what it actually do with respect to adopting Blackwell and all that. Right. Because Blackwell is going to just blow everything out of water, right? And the good thing is that we are collaborating so closely with NVIDIA and engaging on like multi-generation platforms. So we know exactly how this is going to shape up. But without a doubt, we'll be the first one to bring it to customers, and let's see how it's going to help them to do their business better.
Vic, great, thanks for that differentiation. Final question, as you walk the halls, you were there for the keynote. What's the key takeaway? Or if you take a step back, what's the key takeaway for guests from this conference?
I personally think, right? I mean, I mentioned about what kind of customers that we have. Yeah. I did not mention what kind of customers we did not have. The reason is, if you take a look at enterprise customers, they have tremendous amounts of data. They don't know what to do with it. They don't know how to manage it, because they do not have the necessary resources to develop applications and put guardrails on that and run their workloads on that. And Jensen's keynote makes it very clear. If you take a look at enterprise AI, what they're doing with that is providing a framework for all these microservices that NIM based, and which actually can be used on any of these systems, because CUDA is the underlying framework for that. And people can take the data and apply it and develop applications quickly, which will help accelerating the adoption of this in enterprise space, because they are the ones who are pretty much having all our data, right? And by using that in a proper way and being able to create a secure AI environment in a multi-hosted environment, put a guardrails on that, and accelerate the application development, that is the key. I think we are going to work with NVIDIA, and one thing that Jensen said, which actually is music to my ears, is how do we make this adoption easier? Because it's very easy to talk to a bunch of scientists and technical guys, but at the same time, it needs to make business sense. Business is what we are talking about, bridging the gap between technology and business to come up with enterprise workloads and accelerate their their business and whatnot.
Yeah, really almost NVIDIA becoming a software company versus hardware.
I don't think it is becoming, it is, right? And we're talking about, it's not just software, it's not just the hardware, it's basically the environment and the ecosystem that is developed around accelerating everything. I mean, you take a look at what is happening with something talked about like GB272 NVL. I mean, what is it? It's a bunch of words, right? But if you take a look at it, in a single rack, we're talking about almost 720 petaflops of compute. Insane, right? Yeah. So if you take a look at the type of workloads that would never be done in the past within a meaningful power profile and within a meaningful time frame, that we are able to accomplish today. And the only reason it's happening is because of the vision that is behind it in integrating all these technologies, whether it's the compute or the network and the software and the entire ecosystem. So one can take it and run with it. And we are super excited to be part of this critical equation, because without hardware, nothing runs, right? So, and we are that.
Vic, we could keep talking. Unfortunately, we're out of time. Thank you very much for joining us.
Appreciate it. Thanks for the opportunity.
Maybe we can get some candy if you're not too busy.
I think we should do that. Thank you.
Thank you. Thank you, Vic. Thanks, guests, for watching, and be sure to explore more sessions in the GTC catalog. Hello, I'm Matt Marshall, founder and editor-in-chief of VentureBeat. We're here live from GTC 2024 talking with Kurt Kukain, VP of Marketing at DDN Storage. Welcome, Kurt.
Hey, thanks for having me on.
Kurt, tell us a little bit about what your company does.
Yeah, so DDN, we're the largest privately held storage company in the world. We focus exclusively on high-performance computing, accelerated computing, and AI in terms of our storage solutions. And so we grew up in the high-performance computing industry, have been around now for close to 25 years, developing solutions there. And recently we've seen an explosion in interest in our products just because of this explosion in AI. Jensen talked, a year ago that AI is having its iPhone moment, and so we're having our own moment in the industry.
Great, Kurt. Can you drill down a little bit on how exactly storage has changed over the last year? Generative AI just really came about last year. How has it changed exactly?
So I think it's just this increasing realization that the amount of data that needs to be stored and processed and even originally captured is just exploding, right? We're walking around with our own data generating devices in our pocket nonstop. Now our cars are generating terabytes of data a day, and all of that's being fed into some kind of centralized location, and data just sitting there isn't really useful to organizations. And so these organizations now realize they need to exploit that data, and using these gigantic large language models, they now have a vehicle to really mine that data and turn it into useful insights or even new products.
Kurt, okay, that's great. Speeding up to today, GTC, you're here, you saw the keynote. Can you talk a little bit about some of the big trends that you're seeing?
Sure. Well, I think the number one trend, right, is just the explosion in computing power.
Yeah.
Right. Jensen talks about accelerated computing is something about being able to do more with less, and so data centers all around the world are facing power constraints, cooling constraints, even real estate constraints. And so having these really, really powerful chips that can process an enormous amount of data will allow us to continue that amazing curve of just being able to advance applications, advance how powerful applications are for consumers, for business, and all of that is driven on the backside of having that available data. And so through our partnership with NVIDIA, we're along for this amazing ride.
Jensen, CEO of NVIDIA, announced the Blackwell system, the next generation GPU system. There's the SuperPod. Could you talk a little bit about your role, announcements you made with NVIDIA?
Yeah. So SuperPod itself, so we are the storage behind NVIDIA's own SuperPod. So their Selene system, their Cambridge 1 system, their EOS system, and a majority of the SuperPods around the world are backed by DDN Storage.
Okay.
And that's because we do have a unique value proposition within our product, which is we're using a parallel file system, and that allows us to really balance read speed and write speed. Typically, folks had thought that these really large language models were very read intensive, but what we're finding actually in production is that they need both read capability, so read lots of data, but they also need to be able to write, because these really complex models are spread out over so many GPUs that something is invariably going to go wrong. And so you need to be able to checkpoint each iteration, and folks are doing these checkpoints on an hourly basis. They need to be able to write the data down to disk, and you need to be able to do it really, really quickly, and that's where DDN shines, and we do so very efficiently. And so we allow folks to, again, that accelerated computing theme of trying to do more with less, we allow folks to really accelerate their data, either reads or writes, with a really small real estate footprint and a really small power and cooling cost.
Sounds like there's a lot there in storage. I think it counters this perception in some of the marketplace around the commoditization of storage.
Sure.
You know, I think a lot of people were looking at Microsoft's Fabric move as a way to get maybe away from the commoditized storage business. Sure. It doesn't sound that commoditized. Can you talk a little bit about the differentiation you have with some of the other players there? Maybe sure. you just answered that in part.
Yeah, a little bit in part. All right, I think at the peak of the market, where you need this peak performance and also the stability of the system at that peak, that is where we're going to be differentiated from your standard storage. If a company is running just a few GPU systems, let's say 4, 8 GPU systems, then probably any commodity storage is going to suffice for them. But we're dealing with customers who are buying thousands of GPUs. And so whether they're running it as a shared GPU cloud, we have a lot of partners here at the show, folks like Lambda, Vultr, Scaleway in France, Bitdeer in Singapore. These are all folks who are doing really large scale cloud and are able to either give dedicated computing time or shared computing time to a lot of different people. And they have the same challenges as a really big manufacturing company like NVIDIA's designing their own chips. And so they have these incredibly enormous supercomputers that are dedicated to just doing that. The challenges are very similar. And so at that peak performance, it's very different. And then the other piece that is becoming more and more important is really everything else, right? So yes, training is important and training is difficult. It's a really complex challenge, but so is everything else. And so being able to gather that data from the edge, bring it into the data center, bring it into a public cloud, and then be able to do useful things with it is probably the next frontier. And you see a lot of emerging vendors taking that challenge on. And then we also just announced in the last year a new product from DDN called Infinia that is addressing this kind of AI data plane on a software basis, right? So the one thing that we want to get away from is a reliance on hardware, because the hardware truly is commoditized. Okay. Right? There are still certainly vendors out there, including ourselves, who are selling appliances. It definitely makes our life easier, right? We can control the entire environment. But I think what customers are looking for is to be able to utilize the systems that they have in their data center already today to be able to help them design and deliver storage services.
Yeah, this question isn't necessarily so technical, but maybe for the wider market, this is the last question, Kurt, but since you mentioned the value in the chain, right? I think originally there was the thought that, hey, OpenAI had the model, that the value was in the LLM, right, the large language model. Gemini, others have come out, you literally have scores of companies competing at the level, almost feels commoditized.
Yeah.
Then NVIDIA, on the GPU level, has seen massive valuation rate increase, taking over Google as the third largest. So something gets in the hardware or the GPU level. Where would you put it?
I don't know. I mean, I would say, and even I think Jensen said that NVIDIA isn't really a hardware company. They are a software company, right? And so I think establishing the software capabilities, right? There are plenty of folks out there who are doing accelerators on the market, but they really don't have that full stack approach. And the one place where we add the most value in that stack is in the data and in the I/O. And we integrate with the entire NVIDIA networking group. We integrate with the GPU group, and we integrate into the software stack. And so I think that was where NVIDIA has really, truly, created itself a differentiated position from all these other players who, have very nice accelerators, but are maybe difficult to consume. And so NVIDIA has really invested in making this technology easier for everybody to consume, including those folks who are delivering then the end user applications. And that's exactly what we're trying to do too with storage, is make that easier for everybody to consume, and that way they're being able to apply value-oriented decisions as opposed to maintaining hardware, which no one wants to do anymore.
Well, congratulations. Thanks for coming here. We're out of time, but thank you very much, and we'll be following your story.
Great conversation.
Intriguing journey you're on. Thanks, Kurt. So thanks, guests, for watching, and be sure to explore more sessions in the GTC catalog. Hi, I'm Matt Marshall, founder and editor-in-chief of VentureBeat. We're here live from GTC 2024, talking with Jerry Culp, Director of Data Science and AI Solutions at HP. Welcome, Jerry.
Thank you, Matt.
Jerry, thanks for joining us here at the GTC conference by NVIDIA. Now, you go by Z by HP. Let's talk a little bit about what Z by HP is and why you're here.
Yeah, absolutely. So Z by HP, so we have the HP brand. Z by HP really denotes our high compute workstations as a sub-brand within that broader category, so that we can really showcase the compute that we bring to the workflows.
Okay, can you talk about your role as a compute unit in the overall NVIDIA ecosystem of GPUs and why you're here specifically? And I think you made some announcements.
Yeah, we did. Yeah, we're very excited to be working with NVIDIA, and we've really showcased their GPUs for a number of years now in this high compute area. As we get into AI, this is where working with NVIDIA and really helping our AI developers and data science developers out from their creation of AI is really our focus here. And so this is where we've been announcing our AI Studio and our integration with the NVIDIA components, the NGC libraries that we can pull in and help our customers really get a start at what they're doing.
Great. Now you mentioned a broadening of access. I think you have some other programs interesting that you're working on.
Yeah, we do. There's two in particular. One is we've created an AI certification program for our channel partners so that we can help educate them to get to the customers to a broader base and be able to kind of democratize AI a little bit more. The second one is some work we're doing with NVIDIA, going to Nairobi, Kenya, and working with a startup, Amini. And what they're really looking at is how can they help the food scarcity and the farmers there be able to make better decisions in what they're doing so that it can actually kind of go into the hands of the farmers to really improve their lives and the area that they're in.
Yeah, we talked about the variety of applications and industries and countries around the world apparently being affected by this generative AI revolution. Can you talk a little bit about what's driving business at HP or Z by HP? What industries? What verticals?
It's across all of them. One of the things that we see where we've been focused primarily from a legacy perspective with M&E, product development, anything that had really high compute needs. What we're seeing now is that with this transition to AI, it's really across every industry and many, many functions within those industries, whether it's product development or it's marketing, sales. It's showing up everywhere that the companies have data to be able to drive that. And so it's really across the board. And I think we heard that in Jensen's keynote, that it's just everywhere these days.
Got it. Let's drill down a little bit more into the Z product. Can you tell us clearly what the AI Studio is?
Yeah, thanks for asking. So AI Studio is a centralized platform that enables the data science and AI developers to do their work. And to do it, it really combines the data, the people, and the compute together in a centralized way so that as data science and AI development is a team sport, it allows them to kind of come together, get on the same environment, and do it simply. And also by bringing in pre-trained models, it allows them to get started a little bit faster.
Can you talk a little bit about your view on the differentiation of that product relative to the other products out there in terms of the AI Studio or your larger program, Z?
Yeah. So when we look at what we're doing, we're trying to supplement the workflow. Because what we're finding is with the costs that are entailing with everybody getting into AI, being able to start on the workstation, do your experiments, try it out with your training data, then take it to the cloud, whether it's your CSP or the NVIDIA SuperCloud, right, and being able to scale out, having that capability local and being able to curate that and get the teams on the same environment is absolutely critical for them, and we feel like we have a good differentiated solution to do that.
For accessibility, that's great. Can you talk a little bit about some of the key trends you're seeing in the GPU AI ecosystem that maybe you're walking away from this conference with? Any key trends that you're surprised by?
I think it's the speed at which everything is happening, right?
Yeah.
We've been going along for a while, and HP's been focused in this area for about 4 years, and I have seen a huge acceleration. If you look at the size and the number of people that are here, not only the participants, but just the general crowd, it just shows the speed at which this is accelerating, and that is pretty amazing.
Yeah, it's actually hard to walk through. I don't know if you were here last night or sometimes during the day. And this San Jose Conference Center's been taken over, and it's really hard to find your way through without standing in lines. How do you see open source deployments of generative AI, Jerry? Right there's this OpenAI API, which allows companies to have this closed model, and it's relatively straightforward compared to open source, where the idea is a lot of companies for using open source are going to need more control over their data, more say in using their own resources. How do you see that evolving, and how does that affect your business, if at all?
Yeah. So I see that open source has been great. It's allowing people in and to try things out, which is really, really good, with a very low cost to be able to do that. So we see customers that are using it and will probably continue to use the open source. We're also seeing customers that have different demands on what they do, whether it's privacy of data, wanting to own more of it, and have more things maybe local versus in the cloud. And for those, we're seeing that they're actually doing more private models. So there's a lot of companies springing up that are private model companies. And so I think that's great for the whole industry because it gives multiple choices for your kind of barriers to entry and your ability to get going.
Right. Jerry, thank you very much for joining us.
Yeah. Well, thank you, Matt.
Guests, thanks for watching, and be sure to explore more sessions in the GTC catalog. Hi, I'm Matt Marshall, founder and editor-in-chief of VentureBeat. We're here live from GTC 2024 talking with Omri Geller, Run AI Labs CEO and co-founder. Welcome, Omri.
Thank you, happy to be here.
So tell our guests what Run AI actually does and why you're here.
Yeah, so Run AI helps enterprises and organizations to build and deploy AI models quickly and efficiently. So we're helping the organizations to bring the solutions faster to market by providing software that helps them to efficiently access compute power. Compute power is extremely important for people that are building and deploying models, and by providing an efficient access to compute, we're making the users more productive and the organizations have better infrastructure management and utilization with that software.
Got it. So it's almost like under the LLM or generative AI layer, the application layer, you've got this hardware. Most people think of GPUs from NVIDIA. Talk a little bit about that, the complexity of that layer, and maybe briefly how you're differentiated from.
Yes, absolutely. So exactly as I said, there is the compute infrastructure, the GPUs, and then on top there are many different tools that data scientists and machine learning engineers are using daily. All of those tools need access to GPUs, and they are concurrently trying to get access to that scarce resource, the GPU. So the Run AI layer is exactly that middleware that knows how to bridge the gap between the different applications that are trying to access the GPUs and provide access to the GPUs according to business priorities, policies, and according to the business goals, of course. And that's where we differentiate. We're focusing on building that layer that know how to efficiently utilize the GPUs and provide the right access patterns to the different applications so that the enterprise eventually can come quicker with AI solutions to market.
Super. And it's great timing, by the way, because we reported on your, I think your Series B or something a couple of years ago.
Correct.
So you were doing this before the revolution started.
Absolutely.
Let's speed up to today, right? And obviously a lot of growth. What did you announce? I think you had made some announcements today with GTC.
Yes.
Can you talk a little bit about those?
Obviously, it has been a few years since that round, and the company has gone through tremendous growth, and mainly many enterprise deployments. We just had a session with Adobe that is running one of the most advanced GPU clusters in the world, and we had a session with them here at GTC where they explained how they build their AI infrastructure with Run AI and how we help them to build and deploy models faster to production. And the reason that I say that is because we're highly focused on building that AI infrastructure layer for organizations that are building the models. And this week we announced with NVIDIA our certification, Run AI certification for NVIDIA DGX SuperPods, which is the most advanced supercomputer.
Jensen announced on Monday, right? The new SuperPods based on Blackwell?
Exactly, exactly. So the SuperPod architecture now has Run AI certified, so enterprises can buy that AI supercomputer and bundle in the Run AI software and get a full stack AI supercomputer for them to be able to build and deploy models quicker, faster, better, basically.
Got it. You know, I think a lot of the industry, Omri, is waiting for the serious deployments to come online versus experimentation. So there's a lot of questions. Is this overhyped, right? This Gen AI revolution. So you're sitting there creating this middleware for the next SuperPod coming. Are you in front? You know, too far in front, or do you think I guess the question is, are the deployments coming?
Yes, absolutely. What we have seen is that with the revolution of ChatGPT and the large language models, it basically made it super accessible for enterprises to have models and think how they are going to deploy those models in production. The fact that this is models that the interaction with them is language made it very simple for executives in enterprises to envision what type of applications in their business can be transformed using AI. So we're definitely seeing a huge momentum and growth with production deployments of large language models. We cross enterprise, across verticals. It's real, it's not hyped, it's actually growing in a crazy pace.
Okay, Omri, so you've been here for I think a few days here at GTC. I'm curious, what are the biggest trends you're seeing or that you're walking away with? You know, you told me earlier that you're in meetings the whole couple of days. So I'm not going to let you get away free from that. So what are you getting from your meetings? Like, what are you doing?
That's completely fair. So honestly, going back to your previous question, I see that now organizations are really top of mind in taking AI into production. it has been there for multiple years already, but there is a shift. There is a shift that it's really top of mind for C-levels within organizations that are thinking how to build their AI infrastructure right, so that they will be able to deploy models in production quickly and efficiently. And that is the main focus for all the conversations that I have been, I've been with, whether it's with end customers or partners of ours that, together with Fran AI, deploy those basically production clusters for organizations.
In terms of the value of the chain, we were talking a little earlier that the excitement was originally around the LLMs, right? Who had the best model?
Yep.
There's excitement here about the GPU level and what Jensen and NVIDIA is doing, clearly from their market cap. Right?
Yep.
Where do you see the value? Is it the top, the bottom, or somewhere in the middle?
So I believe that first of all, there's value across the full stack, right? From my perspective, however, I would say the infrastructure layer, that is, whether it's the hardware and the software on top, okay, that is the long-term value, since the application layer can change all the time. So, last time it was large language models that disrupted our life, and in a year from now it can be something else. The underlying infrastructure should be able to run any new application that is coming in the future and be bulletproof for the future, all right? And whereas the underlying infrastructure, and that's why the infrastructure is so important, because it should be bulletproof for the future. The top layer of the stack can change all the time. You need to have moat on the infrastructure layer in order to continue and scale and be prepared for the future.
Okay, and last question, Omi, you've been very forthcoming on the deployment, since you've talked so much about that coming online. What, if you may, what are the big application areas or industries that are driving that change? Do you have a sense of where that's coming?
First of all, we see it across industries.
Okay.
We do see that the financial, actually the FSIs are moving very quickly.
Okay. Banks or?
Banks,
okay.
yes.
Hedge funds?
Banks and hedge funds, and yes. All of the FSI, they are really in a big transition towards generative AI right now.
Okay.
All the other verticals moving quickly as well, but definitely I would say that FSIs are, it's top of mind there.
Okay, Omri, congratulations.
Thank you.
Thank you for coming and speaking with us.
Thank you.
Hope
Thank
you
you for
enjoy the
having
rest
me.
of the event.
Yep.
So guests, thank you for watching, and be sure to explore more sessions in the GTC catalog. Thank you. Hi, I'm Matt Marshall. I'm founder and editor-in-chief of VentureBeat. We're here live from GTC 2024, talking with Ian Buck, Vice President and General Manager of Hyperscale and HPC at NVIDIA. Welcome, Ian.
Hi, Matt.
So, Ian, you've just announced, or your CEO announced a couple of days ago, the newest generation of GPUs, the system called Blackwell. Can you talk a little bit about why it's such a big deal?
Yeah, every 2 years, NVIDIA launches a new GPU platform.
Yeah.
This year it's Blackwell. It's the biggest GPU we've ever launched, 208 billion transistors, actually made up of 2 radically limited dies glued together to build one giant GPU. On top of it, that GPU is incredibly fast. It has over 20 petaflops of AI. That's compared to Hopper, the generation before, which maxed out about 4. 20 petaflops is a lot. Our first big supercomputer was the Titan supercomputer at Oak Ridge National Labs with our Kepler GPU back in 2012. That entire supercomputer, about the size of a tennis court, was 20 petaflops.
Yeah.
I can now fit 20 petaflops in the palm of my hand.
Yeah. Ian, I mean, these are just massive computing technologies. There's a conversation in the industry right now about the move to deployment of generative AI, right? The notion is we're still in experimentation mode, but even then there's demand. Can you talk a little bit about who's actually going to use Blackwell, like in the here and now? I know it's coming out later this year, and then what are they using it for?
Yeah, last year we started to see the emergence of not just generative AI in terms of chatbots and interacting in text, but multimedia, multimodal generative AI, where we can type what a picture we'd like to see, and it comes back as a full, beautiful drawing.
Yeah.
Or describe a scene, or even do in the research space, 3D video and animations. Now we're seeing like scientific applications being deployed. Not just the language of humans, but generative AI that can generate some proteins or possible drug candidates for curing different diseases. One of the challenges though with generative AI is that, as the models are getting more intelligent and they can do all of these different amazing things, they're getting larger, bigger, and more capable. Today the state-of-the-art models are 1 trillion parameters. These models are huge. They don't fit on a single GPU, and you need lots of them even to have them interact real time. One of the goals of Blackwell is to take this 1 trillion parameter AI and democratize it. Allow everyone to be able to get the benefit of these giant models and what they can do for the way we interact with computers as regular users, but also industries, businesses, and scientists to be able to use 1 trillion parameter AI for their work, or to improve the outcome of their business, their economies, or even their nations.
Yeah.
Blackwell is going to make it way easier and cost much less to deploy these giant models, and we're super excited to bring it to market.
Yeah, Ian, clearly NVIDIA is benefiting from this. I mean, the market cap of the company has just exploded. I mean, you're third largest market cap company on the planet, I believe now. It just passed Amazon and Google. Are you worried? I mean, you're the product guy, so maybe this is a little unfair, right, in terms of your zone of responsibility, but are you worried about the industry getting a little ahead of its skis, in front of its skis here in terms of the actual deployment and usage of this, right? You're going off and building these massive systems. Jensen was there saying, hey, we still don't have enough, so maybe we're okay, but just coming from your perspective?
It's hard to describe or even track an exponential, and that's what AI has been.
Yeah.
The growth has been exponential.
Yeah.
But it's not without good reason.
Yeah.
The opportunity for AI, which is basically software writing software, you're changing what data centers do. They're not just retrieving information and bringing it back to you, or allowing you to connect with, search for products and purchase things. Now we're turning them into AI factories.
Yeah.
They're token generators. And those tokens generate information that we can interact with and monetize, either by increasing our productivity in terms of co-pilots, or being able to ask questions of our data to optimize some of the business questions we have every day. So if you look at the economics, the tokenomics of data centers now, it's remarkable and dramatic. And that's really why there's so much pull for AI.
Right.
Now, as this business grows and these applications are going to grow, it's tough to predict where it'll all end up. One of the most hardest part of my job is to forecast for all the demand out there. But we can clearly see that the generative AI is game-changing in terms of how we deploy our technologies, use it, and changing all these business practices.
Yeah.
So overall, our job is just to continue to bring down the cost of deploying these models, allowing them to scale further, and at the same time provide an innovation platform so that the AI geniuses of the world that are coming up with the next GPT or next trillion parameter model can have a platform that's capable of doing so.
Yeah, Ian, something I wanted to ask is, how far up the software stack will NVIDIA go? I mean, you're significant here because back in 2004, I think you started this software creep. You were instrumental to developing CUDA, right, which was kind of a software and hardware combination, but the software being, as I understood it, breaking down tasks into ways to parallel process efficiently into chunks, and now speeding up to 2024, 20 years later, you're creating these NIMs, which is essentially microservices, packaging up these AI deployments, right? So all the way up the stack. How far is NVIDIA going to go up the stack?
It's a great question, and we get asked this all the time.
Yeah.
We started obviously with a way of how to program this new kind of processor, GPU, that was originally designed for video games, computer graphics. Figuring out the color of every pixel on a monitor 1 million times over in a 30th of a second and throw it all away and do it again. That's what CUDA enabled. Make it easy for developers to write applications on GPUs. Since then, and fast forward 20 years later, CUDA is not just a way of programming a GPU, but it's an entire ecosystem of libraries and SDKs to let developers do their best work. It's now over 450 libraries and SDKs across not just what NVIDIA develops, but the entire ecosystem is providing on our platform. In addition, we choose where we can accelerate further, to go up the stack, if you will, and make available domain-specific or vertical-specific platforms in the areas of healthcare or EDA or CAD software to help activate those ecosystems, those ISVs, to take the final step to activate, to connect with their customers and add value on top of our platform. Meanwhile, the strategy is always to keep that whole stack open. If someone wants to meet us, program all the way down to the GPU level, they can.
Yeah.
Consume all those math libraries that we've developed, they can. Interact with our vertical domain libraries, they're accessible to help activate and spur this market of accelerated computing. You mentioned NIMs, very important.
Yeah.
You go to a website like Hugging Face, you'll see thousands of AI models, and there's more being added every day.
Yeah.
What NIMs really enable is to build the software microservices, the little building blocks, so that ISVs or cloud applications can easily integrate those models into an enterprise application and know that they're getting the best performance because NVIDIA's optimized those models. They've gone through full security checks, and they're tuned and designed to run amazingly well on NVIDIA in the cloud so that they can integrate it into their cloud application. Basically making AI as a microservice in every enterprise application.
You talked about security.
Yeah.
Right, and that's another component here. So Blackwell has a security component. I mean, I think you're wrapping security around these products and as you move up the stack. Can you talk a little bit about how Blackwell protects AI models and AI deployments?
AI models are extremely valuable.
Yeah.
They basically are trained on all of your company's data,
yeah,
and encapsulated into one model. They represent the IP of your entire company sometimes. And that's why it's important to protect them, to make sure that they're secure. Even if you're running it on a third party's cloud or a hyperscaler data center, you want to know that your AI model is trusted and secure and is available for you and used in your application, but it's not going to leak. Blackwell actually supports secure AI. Every link between the CPU and the GPU now over NVLink is entirely encrypted and actually supports a trusted execution environment. We added this to Blackwell because the growth of these AI models are happening everywhere, and they're incredibly valuable and incredibly important to take to market.
Yeah, Ian, so let's talk a little bit about the networking. Now this is going back down the stack, as it were, or at least conceived as down the stack. Why is networking so important for AI applications, which are running on top?
You know, AI just doesn't run on one GPU anymore.
Yeah.
Actually, for quite some time, when you either train a model, right, or when you're doing inference or deploying a model, yeah, you actually need to collect multiple GPUs together to run these trillion parameter models. Even 100 billion parameter models need multiple GPUs working together.
Yeah.
Back actually in 2016, we started this journey of NVLink. The ability to take multiple GPUs and directly connect them to each other inside of a system so that they can work as one giant GPU. That was critically important both for training and inference in AI. With Blackwell, we've taken the next step up. For trillion parameter AI, particularly the mixture of expert models you've heard of with Google Gemini or Meta's No Language Left Behind, these models actually have lots of smaller AIs all working together, all communicating. So we've increased NVLink to go now from inside of a single server, but actually at rack scale. Now we have a rack scale giant GPU, but we can't stop there. Certainly for training, we need to be building data centers to train these giant models. There we have to connect all those GPUs with every other GPU in the data center so we can train these models at scale, literally over trillions of sample data points. So at GTC we announced the next generation of InfiniBand, the Connect X8 and the Quantum X800, and also the Ethernet equivalents, the Spectrum X800. So whether it be InfiniBand or Ethernet, people can build AI data centers at scale and have the fabric for the entire data center and now the fabric within the rack, NVLink, to be able to train and deploy these giant models.
Yeah, that's an incredible story. We could keep talking, but you're the product guy, and you have congratulations in terms of bringing it to today. I hope you get some vacation pretty soon. Is that coming?
Looking forward to it, yeah.
Okay, congratulations. We're looking forward to following your story in the coming years.
Thank you.
Guests, thanks for watching, and be sure to explore more sessions in the GTC catalog. Hi, I'm Matt Marshall. I'm founder and editor-in-chief of VentureBeat. We're here live from GTC 2024, talking with Deepu Talla, VP and GM of Robotics and Edge Computing at NVIDIA. So Deepu, welcome.
Matt, thanks for having me.
You're at the center of a lot of excitement right now, robotics and AI. Can you talk a little bit about why that's so exciting right now?
Yeah, I mean, there's simultaneously two things have happened in the last 6 months to a year. Number one, as we all know, is generative AI. The cool thing about generative AI is the fact that the models that are coming out of it, the so-called foundation models, are generalizing rather well. And that's perfect for robotics applications. And the second thing that happened, the last 10 years, we've been working on this technology called Omniverse for creating digital twins. And a lot of things that we've been working on have finally come together. So now we have a perfect scenario where we have generative AI and combining it with Omniverse for digital twins. We're able to simulate a lot of these robots in simulation, and as a result, we can speed up the testing and training of these robots.
You mentioned generalizing very well. Can you talk a little bit about like what specifically are you referring to? What areas are generalizing very well?
Yeah, for example, in the past, when we used to do AI, deep learning, convolution neural network-based things, you would train it on a specific thing, like pick something, or identify certain objects, right? It's a people or animals or something like that, or a specific pose. Now, we're able to use one model that is able to do almost all of those things. And so that way, we don't have to train for one specific thing, but it can rather generalize well.
Okay, now let's move to the big announcement from Jensen a couple of days ago. He announced Groot, which was this new robotics platform. Can you talk a little bit about its capabilities and how it's differentiated?
Sure, absolutely.
Yeah.
So there's multiple parts to this. Number one, we think it's time for creating a general foundation model for robotics. Just like ChatGPT is for what it did for the IT world and the general purpose industry, how about we try to create something for robotics that can operate in a fairly general manner? So it's a foundation model that as input, you can give it text or speech, but you can also give it video as input, or even live demonstration. We could put it in Omniverse, for example, and virtually tunnel in, right? And then we train this foundation model on large amounts of data, both from the internet, obviously, but also from demonstration. And out comes a series of actions that the robot does. So that's the foundation model. And then to run that, we need a great computer, of course, right? Because it has to be running in real time at reasonably low power. And so we announced Jetson Thor, which is the follow-on version to the most popular Jetson Orin that we have, which has been adopted pretty much by every robotics company. Over 6,000 companies are using Orin right now.
Okay.
Over 1.3 million developers on Orin. Thor takes it to the next level. It has 8 times higher performance for transformers, which, as you know, is the engine for generative AI. And we also increased the I/O bandwidth by 10 times because humanoids need a lot of these sensors.
Great, that's intriguing. So until now, I think you've had some other competing platforms. So you have the big cloud providers that all have a play, right? Amazon, Google and Microsoft, and they're all actually in the foundation business in one way or another, right? In terms of foundation models. Could you talk a little bit about how specifically you're differentiated in terms of connecting the dots here, the foundation model, the robotics platform?
Absolutely. So if you think about everything that's happening in the data center, which is where most companies are working, there's a big computer. And that's used for training and inferencing or the running of the model. But the robotics problem is a 3-computer problem, as it turns out. You still have the training and creation of the AI model in the data center, and then you have the runtime computer that's in the robot, that's Jetson. And then there's something in the middle for simulating all of this in a digital twin. We call that Omniverse OVX.
Gotcha.
So it's now become a 3-computer problem, and we are providing the computing stack across all these 3 computers. So providing the tools for robotics companies that need acceleration at the runtime. They need tools for simulating both reinforcement learning and synthetic data generation and all the simulation in Omniverse. And then, of course, training the big models, foundation models on a DGX in the data center.
Gotcha, yeah, and I think you could argue that you have differentiation in all those three levels, but I would think probably on the simulation side, when you're comparing to those big providers, Amazon, Google, Microsoft, there's the simulation, but also how it's all tied together, right? Would you agree that that's probably where your differentiation is?
So we're differentiated, exactly. So all the three computers coming together, but at the same time, look, we are an open platform. We partner with each of these companies. For example, Amazon Robotics is a big partner of ours. They're using our simulation Omniverse environment for simulating their warehouses. And then the runtime Proteus robots use our computing systems as well. So we partnered with everybody in the industry.
So Jensen announced, demonstrated some robots on stage, introduced the Disney robots and had some other robots behind him. Can you talk specifically, you've talked about the platform, but what are the applications that are coming and when will they be deployed?
Yeah, I think broadly we think of robotics like three different use cases. One, take things and move them around from point A to point B. Things like in warehouses and logistics, exactly. So those are AMRs, right? The second one is all these industrial arms that are doing manipulation, gripping, and moving boxes. The robots are relatively stationary, but they're moving things around, right? And the third, which is a new form factor that everybody's excited about, is the humanoid form factor. So this GTC, we announced updates to each of those areas. For Isaac AMR, we've created this tool with this SDK called Isaac Perceptor that provides 3D surround vision. So now you can operate the AMRs in unstructured environments. For Isaac Manipulator, we created a series of accelerated libraries and foundation models like foundation pose and grasp, and also what is the right trajectory, the motion, we call it co-motion, for where the robot should move. And then of course, for the humanoid platform, we announced the Project Groot foundation model and the computer.
Yeah, Deepu, there was an interesting demonstration of the Disney robots. I think Jensen, was flawless in his presentation. He was really killing it according to most observations. But there was a time when he turned around and asked for the green robot to approach, but the green robot didn't. Do you know what happened there?
Well, I'm guessing that didn't have all the generative AI done general purpose foundation model implemented yet. Yeah. So it's actually pretty cute that it doesn't have it, but soon, hopefully, when the general purpose foundation models are ready, you can be much more interactive than they were yesterday.
Yeah, Deepu, anything else you're excited about going forward from what's coming out of this?
No, I think just the fact that these two things, generative AI and digital twin technology, have exactly lined up at the right time. I think in the next 10 years, we'll see such a massive trajectory in how fast robotics is going to take off compared to the last 10 years. I think we're going to really see all of these robots come to, labor shortages and all the other issues that we have. They can really come and help the humanity.
Okay. Deepu, congratulations. Hope you get some rest after this, but we'll be interested in following your journey going forward.
Absolutely.
Yeah, thank
Great
you,
talking to you, Mark.
Guests, thank you for watching, and be sure to explore more sessions in the GTC catalog. Thank you.